Hello, Doug Littrell again. It's June 8th, 2017. I'm doing video number 8 today. It's morning here at this time. Anyway, need to make another correction or two of some flub ups in my speaking. Yesterday I was correcting what I had said in video number 7 on June 6th. On June 7th, I was adding an amendment to that because I forgot to convert what I found or believed through my equation that I came up with in 2015, what the orbital velocity of Jupiter would be at Mercury's distance, 3.8 million miles per hour. I forgot to convert that to miles per day. You got to get it to miles per day, then you divide it by the distance, and then you can, find the orbital period of Jupiter at Mercury's distance, which was 2.4 days. And that's what I believe that's probably pretty close to what it truly is. Even though my equation needs a little more refining. The other flub up I had came yesterday when I was talking about that. I said Jupiter had a mass 114 billion times that of Mercury. Now, Mercury is a small planet, but when you consider the sun has, I believe it's 1 million times the mass of Earth, 114 billion times the mass of Mercury would be enormous, an enormous star. Anyway, that's of course false. Where the 114 billion number came from was Mercury is 114 billion times the mass of the asteroid 1566 Icarus. And meanwhile, Jupiter is 654 trillion times the mass of that asteroid. So that's where the 114 billion came from. Actually, Jupiter's mass is 5,748 times that of Mercury. So those numbers were rolling around in my head, and I should have checked before I said that, and I threw that 114 billion number out there, and that was silly. Anyway, also, when I was talking in video 3, reading from that, when you take the same amount of lead, same volume, I mean, not mass, as graphite, I was talking about the amount of carbon-12 atoms, the number of carbon-12 atoms that would fit inside one of per that structure in the graphite, that would fit in the space occupied by one lead atom, and per the structure of the lead block, that say maybe a couple of dozen carbon-12 atoms would fit there. Well, when the Standard Model gives electrons so little mass, and that's making up so much of the volume being occupied, because those shells are, according to the Standard Model, quite expansive, but they have so little mass. Even the largest atoms in the periodic table are given so few electrons, and they have so little mass that it creates a density problem that discredits the Standard Model of the atom. So let's just say if 12 carbon atoms in the form of graphite structure fit in there, they would have the carbon would end up, when you count nucleons per volume, which is what you're forced to do with the Standard Model, then the carbon would have to have, when you weigh the same volume per the lead. The carbon, for its nucleons, it would have to have 175% of the mass of the lead. And I said 175% more mass. Well, it's 75% more mass, not 175. It would have 175% of the mass of the lead. Okay, so that was another, I misspoke, even wrote it down wrong, but I knew better. Okay, what I want to talk about today a little bit is special relativity, time dilation. You know, this is another counterintuitive concept, much like the equivalence principle is. That's why when people were told that, you know, despite a much heavier man pressing down on the earth more than a lighter man, that everything fell at the same rate, and it wasn't tested extensively enough, and that's proving to be false now. Okay, well, this is counterintuitive as well, that time passes at different rates at different places, and supposedly the GPS system depends on relativity to be accurate. That's not true. In my book, I've got a couple of pages on this with some diagrams, some pictures and explanation. And anyway, the adjustment for time dilation and that's an adjustment for how far a body is from a large gravity source, and or its velocity also affects it. In one case, you subtract you add time, and the other one you subtract. Anyway, when you do both of those for the distance the GPS satellites are, I believe there are 24 of those. Okay, and meanwhile, you've got 7 Air Force bases on the ground around the globe monitoring them, in which the adjustment for time dilation, as we're told, has been factored into the system at those Air Force bases, not on the satellites themselves. The satellites have atom clocks. Anyway, the GPS satellites would be experiencing perturbation caused by the moon or whatever, and these corrections have to be made for those as they occur. As they determine something is out of whack, then they make a correction on board the satellite to correct its orbit. They need to be kept circular, perfectly circular, for the system to work like it should. I believe there's 24 satellites in the system. But anyway, the correction for relativity, it's special relativity, time dilation, as we're told, is made at the Air Force bases. And but bear in mind, and this is one day, and it's 37,000 billionths of a second, or 37,000 nanoseconds. That sounds like a lot, but it's actually not much at all, as I'm going to explain. A typical transmission is roughly 1/10 of a second long, and that's whether to ground or ground to satellite, from satellite to ground to satellite. And, you know, for the speed of light, all you have to do is determine that using the speed of light, because radio, of course, travels the speed of light, just like visible light. Anyway, so every transmission is 1/10 of a second, and the correction for time dilation, relativity's time dilation, is 37,000 nanoseconds. And so what you spread those billionths of a second over the course of a total 24-hour day, however. Now, when you take how much of that correction is allotted in 1/10 of a second, because each transmission is individual, and you get a reading from that. There's no accrual or accumulation over the course of the day, over the course of the day, it makes no difference. What matters is what happens in each individual radio transmission. That's all that's being measured, one after another after another, all individuals. And so the only difference that makes per tenth of a second is a ½ inch of radio travel. And a ½ inch has no bearing on the accuracy of the GPS satellite system. Therefore, the accuracy of the GPS system is not dependent upon factoring in time dilation, relativity, special relativity's time dilation. Special relativity, relativity in general, is not therefore verified or confirmed by anything that having to do with the GPS system. Now, tomorrow I'm going to talk more about time dilation. Hopefully I can make a video tomorrow as well, in relation to a clock changing the rate in which it runs, being slowed or sped up. It's possible, of course, for clocks to go haywire. Different things can cause that. Okay, is that actually time changing when a clock runs at a different rate? Is that actually time changing? I want to talk about that a little bit tomorrow. Thank you.